Welcome once again, students. This session will be the continuation of the pointer session. Okay, so in the previous session we had dealt with what a pointer is, and we just made use of a pointer, and we just understood what a address of operators uh, role is in pointers, and what asterisk, that is value at operator role in pointers. Okay, so in this session we will just explore more with respect to pointers. Okay, so whenever you are using pointer, you must make sure that your pointer variables always point to the correct type of data. Okay, for example, when you declare a pointer to be of type int, the compiler assumes that any address that it holds points to an integer variable, whether it actually does or does not. Okay, so whenever you declare a pointer of certain type, make sure that you assign the values of that type itself. Okay, so just with respect to an example, I'll just explain you what are the common errors you make while dealing with pointers. Okay, so suppose you have declared a variable, okay, of type, let's assume that you have declared a variable of type double and x equal to 100.1, and you have a variable y. Okay, and you declare a pointer variable. Okay, so my statement was what? If you are declaring a variable of type if you are declaring a pointer of type int, then make sure that you always assign a integer type of data to the pointer. Okay, so what actually problems, what errors that occur when you perform some abnormal operations with the pointers. Okay, so here pointer p is of type int, and you have declared two variables x and y. Okay, so let's perform a statement like, okay, you are trying to see, whenever you have declared a pointer of type int, then it makes sense that you assign the address of an integer variable, but in this case we'll try to assign address of double variable. Okay, in this case there is a variable x of type double. Okay, so ampersand x. Okay, let's see, we'll just compile this part and see what the compiler says. Okay, okay, the file name is pointer.cpp. Okay, so here the compiler gave you an error that cannot convert double star to int star. Okay, as the variable is of type double and you cannot assign address of double type variable to a pointer of integer type. Okay, so in this case we'll force the address of double type variable to be stored in the pointer of integer variable. How do you force it? Like by performing typecasting. Okay, we'll explicitly perform the typecasting. Okay, what was the error? Cannot convert double star to int star. Okay, means what? We require the RHS, okay, the right hand side value of the assignment to be of type int star. Okay, so we'll perform typecasting. Okay, so int star ampersand x. Okay, now we'll just compile. In this case we are forcing it. Okay, we are forcing the type, we are forcing to store the address of double type variable into a pointer of integer type variable. Okay, by performing explicit typecasting. Okay, so let's compile. Okay, so there is no problem at all. Okay, they see over here, it makes sense. Okay, the compiler has no problem, but actually this is abnormal operation. Okay, why abnormal? Because as I mentioned, what the pointer, okay, when you declare a pointer to be of type int, the compiler assumes that any address that it holds points to an integer variable. Okay, over here the address x, okay, address of x does not point to a integer value, okay, it points to a double value. Okay, so over here there are chances that you get abnormal result. Okay, only in this case only as double is of 8 bytes, okay, and integer is of 4 bytes. Okay, so only considering 4 bytes of the double part, okay, the pointer p starts performing. Okay, so that is abnormality. We'll just see what actually the output will be. Okay, so how do you refer to the value contained in the pointer p? By referring star p. Okay, just say cout value of, we'll just see first what the value of p will be. It is p. Okay, it will hold what? Address. Okay, so just p is address. Okay, if you want the value contained in that p is at that point of time you need to make use of star p. Okay, this is address. Okay, if you want the value, then you should make use of star p. Just we'll just compile this part and see what you'll get. Okay, we'll just see output. Okay, so address of value contained in p is this much. Okay, so it is address of x. Okay, it's not the actual address of x. Okay, we have performed typecasting. Okay, over here some abnormality operation has taken place. Okay, next cout what do you think the value of star p will be? You may assume that there may be some typecasting that the decimal part, the fractional part will be truncated and value of 10 will be stored in p, but that won't be the case. Okay, because p is declared as an integer pointer, only 4 bytes of information will be transferred to what? Only 4 bytes of information will be transferred to star p. Okay, as p is declared to be as integer and double, and it is we are forcing the address of double variable to be stored in p. So at this point of time only 4 bytes of information, okay, out of 8 bytes only 4 bytes of information will be transferred to star p. Okay, so we'll just see what the output will be. Compile. Okay, as you can see, you, as per your assumption, you didn't get the value 100, you got some garbage value. Okay, this is the result of abnormal statements. Okay, so at this point of time this is a statement which leads into abnormality. Okay, so this is ambiguous in nature. This sort of statements are ambiguous in nature. Always remember, whenever you declare a pointer variable of type, suppose int, then you should always point to the address of integer variables. If the pointer is of type double, then point to a double variable. Okay, so if you would have made this pointer as double star p, and at this point of time you don't require this typecasting because pointer as well as variable both are of type double. Okay, save, compile, just see the output. Okay, you get the output as 100.1 because in at this point of time you are having a pointer as well as variable of same type, that is double. Okay, I hope this concept is clear for you all. Okay, so the next session will be dealing with pointer expression. Thank you.